How you feeling? Come on now, let's go. All right.
Wake up.
I know these conferences get boring and everything else, so we decided to make this really simple. Yuval and I are going to have a conversation. And what I wanted you to take away from this is, how do you go back and disrupt data center design to enable innovation? Okay, this is what everybody's kind of struggling with. And one of the things that I've found very interesting is when you get people that actually are not happy with the way things are working, and they decide that they're going to go back and wipe the slate clean. If you start from zero, what can you actually get done? So what happens here is ECL. So joining me on stage here, Yuval Bachar is the CEO, co-founder and CEO of Edge Cloud Link. ECL is here based in the Bay Area, and I'm on Yuval's board. And what I wanted to do is just kind of walk through the innovations here of what it is and why and what the outcomes are. Okay, so we're just going to have a conversation. So Yuval.
Yep.
First off, you've been in the industry how long?
In the general industry,
Just
35 years. In the data
35
center,
years. All right, so
data center industry, about 20.
There you go. We're both gray-haired guys. So 35 years, both of us in the industry. We've been through a lot of different companies. But okay, you went out of hyperscalers. You've been in product companies. You've been in all these things. You've built massive amounts of capacity around the world. Mm-hmm. You learned a lot of things. What is ECL?
So ECL came as a output of many years in the hyperscalers and non-hyperscalers, in co-locations, in specialty data centers, in the product side of the world. ECL came and actually said, we're going to develop a new category of data center, which is fully sustainable, off-grid, high performance. And we actually targeted high performance before AI, so we actually dropped exactly where AI wanted us to actually drop. And that data center should be available for everybody. It's not just a handful of companies in the world that can actually build those data centers. It's data centers that anybody can get as a co-location, as a modular block of 1 megawatt, and build it as much as you need. You don't need to pre-commit to 500 megawatts to do this. You can do a 10 meg, a 50 meg, or 100 meg, or 500 if you want.
So I hear a lot of people talking about these things in this way. Great, modular data centers, and we're going to go back and have density and liquid cooling and all the different things. So what is the differentiator for ECL?
So in ECL, we did what Dean was talking about earlier, and we took an approach of, instead of real estate trying to build engineering into it, we took engineering clean slate and build on top of it real estate. We took a clean slate of data centers and said, okay, what do we need to do to build the best data center in the world? And because me and my team came from hyperscalers, large projects, small projects, we knew what does the best of the data center in the world means today. And we said, okay, how do we do better than that? And when you start with a clean slate, you get an opportunity to do a lot of things which are very different. We created three main pillars to our data center. One is it has to be sustainable, and sustainable without buying credits or playing any kind of economical games. It's really sustainable. The second thing, it has to be high performance. And the third thing, it has to be available for everybody. So that built for us the power architecture from scratch, cooling architecture from scratch, and then go to market from scratch to enable us to go to any customer that wants to do this. How we build under it, there's a lot of work that has been done to build under it, and it basically eliminated a lot of conceptions which were in the market to saying, I have to build a data center this way. For example, how many data centers in the world do not have a UPS in them? Probably none. We don't have a UPS in our data centers. How many of them don't have diesel gens as backup? Probably none. We do not have diesel gens as backup. We redesigned the whole thing to operate that. But we did it without compromising the quality. We did it without compromising the uptime. Our sites are going to be rated for Tier 4, which is very, very strong data centers, very difficult to achieve Tier 4. But because we designed bottoms up, we were able to do that. And that gives us a situation that we can build a solution which is very, very high-end, very available to what you need, and probably the most critical aspect today, off-grid. Because the grid right now got to the point that it's saturated, it's not available, and the solutions that every company that you hear daily announcement, I'm going to start a new nuclear plant, I'm going to buy SMRs, but everything is in 2030, 2035, when the problem with AI that we have is now. It's not in 2030, it's not 2035. Today, we're sitting in an environment where there's 1.5% availability of space in the United States. That means there's nothing out there. And if the demand is true, and let's assume that it's actually 50% of what we think is true, is there's a demand of coming of tens of gigawatts coming at us, and anybody who's building data centers or filling up data centers with equipment have no idea how we're going to build it. And we are creating an environment where we can show a sustainable data center that will drive the future with sustainability, but will not compromise anything on performance, on availability, on efficiency, and do it at a price which is competitive to the traditional data centers. A lot of the things that we've been asked, before we go to the next one, is how much premium I have to pay for that data center, this super duper data center? And the answer is none. We are competitive to any data center out there, and we can beat most of the data center out there, both from the price of energy, as well as from the price of actually renting the space from us.
Okay, so you dropped a few bombs in there that I want to go back and pull out.
Hydrogen bomb.
Let's not do that one. Okay. So number one, off-grid.
Yeah.
Number two, no UPS and generators.
Yeah.
And I think you mentioned, or you just hinted, this is with hydrogen power.
Yes.
This is not the future. Literally, it's hydrogen-powered data centers today.
Yeah.
Okay? Off-grid. So let's walk through that.
Unpack
First
that.
off, okay, how do you build a data center off-grid and ensure that you're going to be able to meet the SLAs?
Yeah. So there are two things. When you build a data center at that level and you off-grid, you have to address the availability of power. You have to address the availability of the site itself. And you have to assume that your customer is actually used to the fact that the grid is always there, which is not always true, right? If you live in California, you know that the grid is not always there. But let's assume the grid is over there. What we had to do is we had to actually go and double up our design to a point where we actually demonstrate capability with level of redundancy, which is unheard of in our industry. We took a technology, which is a fuel cell technology, and we said, okay, we're going to power that technology for power, generating power to the data center with hydrogen. Why hydrogen? Because hydrogen is the only fuel out there that you can generate energy with, and it's zero carbon coming from the generation. And not only it's zero carbon, you also produce water in the process, which is also part of sustainability. Sometimes we don't care about the water because it's not expensive, so you can actually lose a lot of it. But in a lot of places, water is scarce. And you need to actually think about how much water you're using. So that's the first level. We said, okay, we take hydrogen as a base source, create a power generation unit that we created based on existing technology of fuel cells. We did not have to go and reinvent cold fusion or something like that. We took existing technology of fuel cells, combined it in a way which is highly available. So we undersubscribed it. We took a data center of 1 megawatt block, and we built for it a 2.5 megawatt power generation system, which gives us by default the 2n+1 redundancy into the system. Then we did exactly the same for every other element. If every element from the feed of the hydrogen all the way to the rack is 2n+1 in every component. And that's how we got to the point that we can come to a customer and say, this data center is just as available, if not more available, than the data center that you see, which are connected to the grid, assuming that you can get the grid, right? So initially, we were competing against grid-connected data centers. Right now, we're competing against no grid connection data centers, which is making the things even more attractive. Now, the big question that comes into play is, where do you get the hydrogen from, right? Hydrogen does not come very natural for people, and in some cases can be a little bit scary to people, right? Because a lot of things have been associated with hydrogen which are not healthy. And we got to the point, and it took us 2 years of negotiation, discussions, partnerships with hydrogen suppliers, that we can get hydrogen supplied to any size data center, and the one we announced last week, we'll talk about in a second. And we can also get hydrogen in liquid state for any location that we need. So there's no location limitation on where we can put the sites. We can put the sites anywhere. At large scale, we need to be close to where the production is or to a pipeline. But that's how we solve the problem of I'm not on the grid or off the grid. What happened? What's the outcome of that if we're off the grid? The outcome of that is we can deliver data centers in 9 months. And that's unheard of in our industry. Today, if you go to the largest data center operators, including the hyperscalers, and you say, build for me 250 meg, that's a 3 to 4 years project. We can turn it around in 9 months to 15 months, the whole 250. And that's the reason for that is we do not need to talk to the utilities. We do not need to get the permits. We're not building substations. We do not need to buy 10 kVA or 20 kVA transformers. We don't need to do all those things. And that gives us, again, an ability to move fast and deliver to the customer a data center that they don't feel it's compromising anything from what they're looking for. On the contrary, they get benefits like very high level of efficiency, very high level of availability. Now, we are in the process of getting the Tier 4 qualification formally. We're not there yet. We'll get there. But on design, on paper, we are Tier 4 level.
And let me go into that, because I think, just to remind everybody, off-grid, right? All data centers that we've been building in the past is I need to rely on the utility. And then the utility is going to have instability, which means I have to put in resiliency in between it when it goes offline, and assuming it's going to go offline for a long duration. So basically what you've built is an off-grid, fully sustained data center when it comes down to power generation. And you remove those layers by up-leveling. So in other words, all the electrical design, the cooling design has got redundancy built into it, which means you basically put the UPS capabilities in other elements higher up. Explain that a little more.
Okay, so what we did from an architectural perspective for power, when you're off-grid, so the grid they have multiple functions. One is stability, it's always there, but it also can actually sync and push very fast transients, which is becoming a very, very big problem right now with AI.
Right.
Now, when you're off the grid and you go into diesel gen and UPS in traditional data centers, then you have a 96 hours window before you need to replenish the diesel in the site, and you operate that way. What we did, we took a different approach. We took 4 independent sources of energy, combined them in an active-active mode. So which means all the power sections of the data centers are always active. The battery storage that we have, which many hours of storage, are actually active, can push the data center independently. So let's assume hypothetically something happened to the redundancy that we have within the hydrogen, the 1+2 on the supply and the 1+1 on the generation. The batteries will hold the site for 8 hours independently. But the batteries are doing other stuff for us as well. They're not backup. They're actually doing shaping. They're doing a lot of aspects that we need with AI workloads, which most generators do not behave very well. I don't think a lot of companies did enough testing with AI loads running on diesel gen. I think they will do that. That will get a surprise. They will get a surprise how the diesel gen actually responds to plus or minus 35% up and down in a matter of tens of milliseconds. Diesel gens don't behave very nicely at that. So that architecture, which multiple active solution, gave us the ability to generate a higher level of production of data center quality for data center power quality for delivering to the AI loads.
Got it. And so I'm going to fast forward to a few things here. So if you look at it, basically it's an off-grid data center that has its own power generation with multiple levels of resiliency built into it that are active-active. Very different, right? We're not going back and putting pieces in here for the case of a fault. It's all built into the design, which means you can remove the generators, UPSs, and you can get to an SLA that's still 5 nines. It's pretty powerful. So the second one is now the cooling aspect of this. Your byproduct of the fuel cells is water. So are you water neutral?
So we're water negative. So we give back water to the community. We're producing many more gallons of water, and it's DI water. We give it back to the community. But the one that we do use, we take into the data center. Our data center is based on liquid cooling to the racks right now, and next year is going to be a combination of liquid cooling to the racks combined with direct on chip. That's going to be in 2025. It's going to be all ECL design, so we are designing our own platform to do that because we want to optimize. Now, when we take the water as a byproduct from our power generation system, we take it and we deliver it into our system in 2 ways. One is we deliver it into the loops which are running the inside, but it enables us also to use evaporative coolers, which are very, very heavy in consumption of water, and most companies are reluctant to use them because of the amount of water that we use in them. We don't need to do that. We can actually use the water because we have the water. As a result, the combination of all of this together bring us into a PUE of 1.06 over here in our site in Mountain View, and in Texas, when it's a little bit more humid and hot, we're going to be around 1.1. That is the level that we are offering on a small 1 meg block, right? I think even the hyperscalers had a really rough time to get to 1.06 or 1.1. They have to be in a certain location. I can tell you from my past life, Primeville for Facebook was one of the first ones which are doing PUEs like that. It was difficult. It was not simple to get there. And we were able to achieve this in a more traditional way. The other beautiful thing that we created with this is that we created a data center which does not need isolation of hot aisle and cold aisle. So we can compress the site because when we use rear door heat exchanger with water, the whole data center is running at one homogeneous temperature. So we put a megawatt on 1,000 square feet, which is about 9x or 10x better than most data centers today. And we can do it with 50 to 75K per rack today, 150 per rack next year.
Okay, so 1,000 square feet, a megawatt, super dense, super efficient, PUEs of 1.1 to 1.06, depending on location, trailing 12-month average type thing. Yep. So this is not just points in time. Yeah. Okay, and we're running out of time here, but your first customer happens to be my company. Yeah. So I am so into this. We are rolling out next week 1,700 GPUs into his facility here in Mountain View. You need to go look at it. This is off-grid, hydrogen-powered, AI, right, enabled data center turning like this. Yeah. Okay? So the other part of this is that you talked about the cost element. Yeah. Okay? The point being that whatever you're actually paying for out there, think about it. That price you're talking about is with on-site generation, no UPS, no generators at density with those efficiencies. Yep. It's incredibly powerful. So I'm getting the benefit as a customer. Thank you very much for that. But the bigger part of this too is we are driving towards a sustainable future. Whether it's the materials that we're building this from, to the actual equipment that's going inside of it, to the energy that's being generated and used on the site.
And that was our goal to start with, right? Define a fully sustainable data center, which is really fully sustainable, zero emission, zero water, scalable, sustainable construction where we use special methods of construction. The last thing that I want to comment is how do we scale? How do we make this big? So we have multiple agreements with suppliers of hydrogen to deliver to us very large quantities of hydrogen. And last 2 weeks, we announced a 1 gigawatt site, which is the first site of probably multiple of them we're going to put in the US in the near future, which are 1 gigawatt of hydrogen-based power, zero emission, zero water, and at first it's going to be a blend of a gray and blue hydrogen. At 2026 it's going to be blue and gray and green, what we call turquoise hydrogen, and then we're going to shift more and more to green. People ask why not green from the first day? There just isn't enough green out there for the demand that we have for AI. So if we're not going to stop building the data centers which are sustainable based on the stock feed, we'll get as much as we can green, and that's our target. We have one more model, which is not directly on the pipeline. It's directly associated with generation of energy based on sun or wind. We put our data centers behind the meter with them, and we actually run it directly. That's something we call from the sun to the server, because that's the ultimate situation we can get, that with generating the energy from the sun, we generate hydrogen on site, we do storage, a direct feed from the sun to the data center, and create the same tier 4 level of data centers, which are associated with renewable energy generation.
So the punchline of all this is that hydrogen is not 5 years away. It's live in production right now here in Silicon Valley at 1 megawatt and is going to a gigawatt in Houston next 12 months. So it's real. Everything is happening in this one, and I'm very proud to be your first customer. I'm proud to be part of this innovation and breaking the mold. So thank you very much for your leadership.
Thank you, Dean.
Appreciate it.
Thank you.